Okay, so here we go with our last video on trigonometry. We can use the primary trig ratios. So that's sine, cosine, tangent, to solve problems that can be modeled using right triangles. What we're going to look at today is problems involving more than one right triangle. But again, the idea is going to be the same. If we can make more than one right triangle, what we're going to be able to do is, to answer questions, we're just going to have to do a few steps. So that's the big idea today. More practice doing trigonometry, and today, well, there's a few steps involved. So here's our first example, and as we go through these next two examples, I want you to think about what information seems to be the most important in order to ultimately ask the question. So in our first example, we want to calculate how long yz is. And I'm going to make it a bit easier. I'm going to label yz as little x, the side opposite angle x, which is our right angle. If we look at this picture, we have two right triangles. We have the left one and the right one. And what we should notice is that triangle, I'll call it WXY, has two pieces of information. And triangle XYZ only has one piece, of information. And as we know, in order to answer questions about a right triangle, we need two pieces of information, be it two sides or an angle and a side. So in trying to ultimately answer how long is side x, which is the hypotenuse of the right triangle, what we really need to be able to do is get another piece of information. And it wouldn't really matter if it were this side or if it were this side. So if we could determine one of these sides of this right of the triangle XYZ, then we'd be able to answer the question. One of these sides is going to be more straightforward, and the one we really want to figure out is this green one. If we could figure out the green one, so given that we have an idea what to do, this means, well, I have to deal with the triangle on the left first, figure out how long that green line is, and then use that information to answer the question I really want to answer. So let's go ahead and do that. So let's look at triangle WXY. And I go through my logic. What do I know? Well, I know angle W. And relative to angle W, I know this side right here. And that side is adjacent to angle W. And I want to know the green side, and that is opposite angle W. And right now, it should just jump on our head with all the things we've done. SOHCAHTOA. Well, there's the O and the A, and there's our tangent. So our tangent ratio is the tangent of our angle, and our angle is 35 degrees, is equal to the side opposite. Well, I'm going to call that little w. Again, letters opposite angles are the lowercase over the side adjacent, which is 18. And I'm going to go ahead and solve that. And I multiply both sides by 18. And when I do that, I get W is equal to 18 tan 35. And when I push those buttons on my calculator and I round it to 4 decimal places, because this is an intermediate calculation, I figure out what side W is. Now that I've done that, I have to use that information in order to answer the question. And ultimately, what I have now in the right side triangle, triangle XYZ, is I have two pieces of information, and now I should be able to go ahead and answer the question. So let's have a look. triangle X, Y, Z. Okay, well, what do I know? What do I know? Well, I know angle Z. Angle Z is equal to 40 degrees. I know the side opposite angle Z. That's the one we just figured out. So I know the side opposite angle Z, and I want to know X, which turns out to be the hypotenuse of that right triangle. Again, going with our SOHCAHTOA, there's the OH, and that points me to the sine ratio. And now it's just a matter of plugging the right things into the right spot. So the sine of our angle is going to equal opposite over the hypotenuse. Recall that our angle was 40 degrees, angle Z. The side opposite, well, that's the one we just calculated. And X is what I'm calling my unknown side. That's the ultimate answer to the question. And what we see in solving this question is an example when the unknown is on the bottom, and we should have done enough of these where we really know automatically that here's the idea of when we switch. And when I do that calculation, and my calculator spits out 19.6 centimeters. And with these, we always want them rounded to 1 decimal place. So there's our first example of solving a question that involves more than one triangle. And really what it does is it involves doing some more steps than what we've done in the previous 5 or 4 videos. So I have a quick little question I'd like you to think about. And my question is, what might we call side W? So with respect to both triangles, what might we call what I'm labeling side W, the highlighted area? And what I'd like you to do then is to tweet hashtag NickMath45 with what word or phrase or whatever, shouldn't be that long, what makes sense to call side W in that particular picture. Okay, let's look at one more example. Here's an example straight off an old provincial exam, and I betcha you're going to see this. You're probably going to see this. So here the basic story is you're on top of a roof, and you look up to the top of another building that's across, and you look down to the base of the building that's across, and the question is asking how tall is the other building. And again, language we see, angle of elevation and angle of depression. And that's already in your notes. But just to highlight, remember our angles of elevation and our angles of depression are always to the horizontal. So the 31 degrees you're looking up, the 42 degrees you're looking down. And we always arc out, if you want to think of it that way, from the horizontal. So there's the picture drawn for you. And the question is, well, how tall is this building? So we really want to know how long we want to know how big this line is. But I hope you see that's really not what the big idea of this question. The big idea of the question is, how long is this side of the top triangle? Because what I already know that this side of this triangle is 39 meters. And that's given over here. So again, the horizontal line gives us some information. The next thing we really want to do is we want to label our triangles. So I'm going to label this A, B, C, D. So now I can talk about the two triangles. So again, what we see is here, we see two triangles. We see the top triangle. So triangle ABC has one piece of information. Triangle ACD has two pieces of information. So before we can answer how long is that turquoise line segment BC, what we're going to have to do is we're going to have to figure out one other side of that top triangle. We can do the hypotenuse side, or we can do the horizontal line side. And I'd like you to think about one sec, well, which one do you think is going to be the easiest? And hopefully what you came up with is we need to figure out that piece of information there. Given that we have two pieces of information on the bottom triangle, we should be able to go ahead and do that. So again, we're going to look at triangle ACD. And we're going to try to figure out how long that, geez, I don't even know what color that is, magenta. We're going to have to figure that out. Say, what do I know? Well, I know the angle. And I know CD is 39 meters, and that side is opposite our angle that we know, 42 degrees, and I want to know that highlighted line, and that's the adjacent side, and that tells me, hey, SOHCAHTOA, SOHCAHTOA. We got the T and we got the O and the A. So let's go ahead and use our tangent ratio. The tangent of 42 degrees is equal to the side opposite over the adjacent. Well, I'm going to call that, I'll just call that X. So here's our X. And in doing that, we solve our equation, and I end up with 43.3139. Intermediate calculations to 4 decimal places. Now what I know is, in the top triangle, I have an angle and I have a side, and I should be able to figure out the other side. So let's look at triangle ABC. So triangle ABC, what do I know? I know the angle, I know the side adjacent, and I want to know the side opposite. And again, SOHCAHTOA, that points me to the tangent ratio. And in this case, the tangent of the angle, and our angle is 31 degrees this time, is equal to the side opposite, well, let me call that little a. Little a opposite big A over the side adjacent, which is 43.3139. And in solving this kind of equation, we multiply the 43.3 stuff over. Let's clear the denominator. And little a is equal to 43.3139 times the tangent of 31 degrees. And when we get that, we get 26.0256. So that's how long little a is. And in order to answer the question, which is how tall is the building, what we want to do is we want to add, so the height is equal to, well, the 39 that we know and the 26 that we added, that we calculated, and we end up with the other building is 65 meters tall. And again, I have another little question that maybe helps you answer the question on the first page. What might we call side X? Okay. So there's the end of the examples I want to do in the video. But here's what I want you to do right now. For next class, come prepared to discuss the following problem. And the problem is, what is the perimeter of this regular octagon? Octagon has 8 sides. Regular means Regular means all sides are equal and all interior angles are equal. So an equilateral triangle is a regular triangle. A square is a regular quadrilateral, and so on. So come prepared to answer